Welcome to the fifth and final episode of See Chris Learn. It's been fun, learning about planets and rocks and stuff, but fun must always come to an end. Hopefully, though, I wasn't the only one who learned something. Today, I'm going to talk about volcanoes. I'm getting all of my information from two very interesting books that I checked out. The first one is this one. The Volcano... Oh, that's backwards. That's okay. It's called The Volcano Adventure Guide by Rosalind Lopez. Lopes. I don't know. It says S on the end. Anyways, it explains about how volcanoes are formed, and it talks about volcanoes all over the world, and it gives you sort of like a practical guide to like visiting one of the, there's more than just, but a choice of 66 active volcanoes if you want to visit them. But if you haven't noticed, I'm kind of obsessed with Venus, so I also read this book, Volcanic Worlds, and I focused on Chapter 3, which was entitled Earth's Evil Twin, The Volcanic World of Venus. So that was really interesting, and if you're interested in learning more about that, it's just a really well-written book, and I would highly suggest it. Now on to the good stuff. Now, as you know, hopefully, after listening to me ramble on and on and on about volcanoes, they're created when hot material in the mantle rises to the crust, and whoop, volcanoes born. But I've also mentioned that there are different kinds of volcanoes, yes? For instance, there are the Luna Maria that I talked about, the moon seas. Now, you didn't see a volcano in that picture. Even though it was focused in, closer, you wouldn't have seen a volcano if it had been, pulled further back and you could see the entire length of that Luna Maria. There is no real volcano there. When I first talked about the Luna Maria, I said that there's an impact cracking the surface of the moon and creating these volcanic plains, right? But I don't think I made clear at the time is that the volcanic plains of the Luna Maria are, in this case, not actually caused by what you think of as an eruption. You see, lava, like all liquids, has a viscosity level. So sometimes the lava is highly viscous and spreads slowly, kind of like, I'm going to say brownie batter. It spreads kind of like brownie batter. Imagine if a volcano was oozing brownie batter. And if that's not a delicious image, I don't know what is. But other volcanoes have a lava magma that has a very low viscosity level. And that lava is more runny, like water in some cases. So the Luna Maria on the moon were created when an impact literally just cracked the surface and allowed the low viscosity lava to spread and create the Luna Maria. No eruption, no mountain, just flat plains. Another thing about volcanoes, they're not all as exciting and deadly as, say, Vesuvius or Mount St. Helens. If you studied either of those eruptions, you know that they basically literally just blew the top off the mountain. Gone. That's the reason that Pompeii and Herculaneum were preserved in deep ash. It's just powdered Vesuvius. If you look at the modern day picture of Vesuvius, and if you in your mind draw lines from the slopes of the mountain up to create a full triangle at the top, that is how big that mountain used to be, and all of that just went boom. But there are other kinds of eruptions. Shield volcanoes, for instance. Shield volcanoes are created when a high viscosity lava, or I guess it's magma while it's still within the volcano. But anyways, high viscosity, really hot rock material doesn't necessarily erupt out of the top of the volcano, but instead like vents out the sides. So then there will still be a caldera on top, like what you think of like the pit where the magma hangs out and then explodes up into the sky, but instead that caldera is not where the magma was, it was the rock on top of the magma chamber, and when the magma oozed out the sides, that rock just sort of collapsed and created a caldera. Shield volcanoes are very wide then, they're not necessarily very tall, because it's just, imagine, you've got your mountain thing here, and other mountains are going to go and big things happen, but in this case, the magma just goes whoo and creates like a big shieldy thing. Now, viscosity in lava, magma, is determined by a number of things. In the Volcano Adventure Guide, the author lists them as, and I quote here, chemical composition, temperature, the amount of dissolved gases, and the proportion of solid materials such as crystals. Now, it sounds maybe a little complicated, but it's actually pretty simple. Basically, there's basaltic magma, which has low levels of silica and a low viscosity. Highly silicic magma contains more silica, obviously, and that creates a higher viscosity. This is because silica forms like really strong bonds with oxygen and with itself, and it creates this sort of tetrahedra composition, which causes the magma to thicken. Crystals also play a large part. The more of the volume, like the volume percentage of the magma that's taken up by solid crystals, the higher the viscosity. So again, basaltic has a lower level, or a lower percentage, I guess, and the silicic magma has a higher. Now, of course, temperature and gases also play an important part. Obviously, the higher the temperature, the more viscous the magma will be. However, if you were to compare two eruptions, one with a basaltic magma and one with a silicic magma, that had happened at the same temperature, the silicic magma would still be more viscous than the basaltic magma because of the chemical composition of it. So it all sort of ties together. It's not just the temperature, just the chemical composition. As for the gas, the way it's described in the book is literally, the gas makes the bang. Here's the quote. Without a significant amount of gas, even the most viscous magma will not make a big bang, but just ooze out slowly. I love that word, ooze. Now, as for Venus, everything I've said holds true. Rock is rock is rock. The tessera terrain that I talked about in the last episode, I think, is believed to be granitic, which means it's basically like granite, and granite is highly silicic. That is just a weird word. Anyways, but images returned from the Soviet lander show that other, like, volcano eruptions, look like basaltic lava flows from Hawaii, but we don't really know the exact composition of the rocks on Venus. In her essay in the Volcanic Worlds book, Ellen Stoffen spends a bit of time explaining how the exploration of Venus the exploration and understanding of Venus could help us here on Earth. I'll quote, "Many questions center on the geologic evolution of the surface and interior, and why the planet has evolved so differently from Earth. After all, Venus is closest to Earth and in size and orbit, so nobody really knows why it's so different." That's literally why the chapter title is Earth's Evil Twin. Let's see, she talks about how much we could learn from information from Venus, such as seismic data and the composition of the surface, but all of that information is really far off into the future because we'd first have to create a material or a craft that could survive on Venus, which is a little ridiculous because it's about 900 degrees Fahrenheit and there's about 90 bars of pressure, which is basically pancake-making material in the atmosphere. So, I talked about konomans in, I believe it was the second episode of this series. So I actually spent a lot of the semester studying konomans, and not just the volcano, but also the goddess. And as I had said, it is really hard to find information about an obscure African goddess, but I did it. It happened. This unassuming looking book right here is called Lady of the Beasts, and it is a cornucopia of information about female animal goddesses from all over the world. It's really interesting, actually. My info, of course, comes from the chapter on bird deities, and there was one sentence, and it clicked into place. It made sense. Here's the sentence. "The symbol of the African Sunufu tribe is the bird woman called Kono, evidently their female ancestor." Female ancestor, of course. Now I could be wrong about this. I probably don't have all the information, and but using what I work with here is the conclusion that my logical, college-trained brain jumped to. The first woman, you remember the unnamed one who gave birth to the twins? That was Kono. Mind blown. Anyway, the book goes on to say that Kono's symbol was that of a crested crane, which is really cool and kind of majestic, I think, but that's a different story. And anyways, the Sunufu tribe's sacred masks, which were so sacred that in fact they weren't really studied up until pretty recently. Just because they were kept secret, because they were sacred, which I guess makes sense. Anyways, these sacred masks have elongated beak faces, and they're really big. They're 5 to 6 feet tall, and when someone wears them during a ritual dance, the wearer of the mask becomes the deity. So here we are. It's all come full circle. Volcanoes and birds and goddesses and all of that. I sincerely hope that anyone watching this show has learned at least something new about planetary geology or mythology. I'd really like to thank my professors, Julie and Tim, who helped me out with all the. Julie helped me out with all the planetary geology stuff. She, taught me everything I know. And Tim helped me with the how science functions in popular culture, this is my experiment into how science functions in popular culture. You're the popular culture, I'm the science. Woo! I'd also like to give a shout out to Paige, the research librarian who helped me find this book. She's beautiful, and you should hug your nearest research librarian. So here it is. For the last time, I'm going to say it, you're going to hear it, it's going to happen. Rock on, my friends, and keep it classic.